Good day, everybody. We're given quite a bit of information. We're given at the beginning of the problem that there are three two-digit prime divisors of this huge number, 2 to the 55th minus 1. Okay, so that's quite a bit to start with. You know, that's kind of limits your responsibilities. It didn't say find all of them, just that there's three two-digit prime divisors of this huge number. Okay, now, of course, factoring has got to be the approach here. It's not written in factored form, it's just two terms. If we can write these two terms as a product of factors, we may be able to identify prime divisors. Now, this fact, I'm not going to write down the formula for this. There's a cool way to remember this that I want to show you. Notice that right here, this product gives us minus 2 to the 50th, right? But if you just hop over to this next piece right here, we get plus 2 to the 50th. So you see, these would be two terms in this expansion, but they cancel. They're additive inverses. This plus this equals to 0, right? And something similar would happen if you went to the 40th power. Okay, you could see that minus 1 times 2 to the 40th would give you, if you went 2 to the 5th times 40 gives you 2 to the 40th, but this against this gives you 2 to the 45th, but this times this gives you minus 2 to the 45th. So the same kind of thing, and I won't clutter it up, but you can see this is going to happen again right here. You know, when you do 2 to the 5th times 2 to the 40th, that gives you 2 to the 45th. But then if you do minus 1 times 2 to the 45th, you get, again, it's additive, and that goes on forever. This is, I've heard this called telescoping. But anyway, the nice thing about this is that we end up with a factor that's already a prime number, namely 31. Okay, so this has got to be one of the answers, right? If you can live with this given information that there's three two-digit prime factors. We found one. Well, you go, what next? Because this is a big number here, 2 to the 50th plus 2 to the 45th. With no discernible way to really factor that, at least for me, okay? But we catch a break right here. We can just go in reverse here. You see, 2 to the 5th raised to the 11th is certainly 2 to the 55th, but so is 2 to the 11th raised to the 5th, right? And so you get the same kind of thing going on here. Again, I'll show you just for the, you have this, right, giving you minus 2 to the 44th. Okay, and then you get this by laws of exponents giving you plus 2 to the 44th. So in the same kind of way, you're going to get a lot of mass cancellation, okay? So now the big part here, though, this is a bigger number. This object right here, it's not too difficult to show that that's 2047. Okay, 2000. You guys that do computer programming or hexadecimal, you almost have that memory. 2 to the 12th is 2048. Subtract 1, you get 2047. Now, there's a check to determine if this does have any prime factors. You're told in advance that there's 3 prime two-digit divisors, and so you would expect this to have a prime factorization. However, a priori, you wouldn't know that. And so you have to look at all the primes that would be divisors of the square root of 2047 or less. In other words, all you have to do is work your way up to that number. Now, I'm not sure how big that number is, but it is, all you have to do is check the primes. And the first one that actually works, I'm not going to go through all that with you, but it would be 23. Okay? Now, once you find out 23, and it is tedious, folks, you would technically have to check. You don't have to worry about 2 or 5, right? And it doesn't look like you have to worry about 3. You don't, because the sum of the digits. But after that, it's just, there's even a test for 7. Okay, but basically it's tedious to discover that 23 is the first prime divisor, okay, of 2047. And then once you do that, you can do a division and you'll get 89. Okay, and a lot of you probably can see mentally that 23 times 89 is 2047, right? Because 23 times 90 would be what, 2060? So, or what would that be? Yeah, 90 2070, maybe 2070, and subtract 23 away, and you would get 2047, right? So these are our other two prime divisors, merely by doing this factorization. Now, there are two others that are larger than, and I would not know how to find them. I would not know how to begin to find them just based on what I'm doing here. It's beyond me how you would do that. You could try to factor out a little bit here, but you're always going to have that one left. If anybody knows how to do that, let me know. But that's why I made the problem the way I made it, is that that I didn't know what to do other than this factorization. Okay, so what do we have here? 31, 23, and what was it, 89? Yeah, 23 and 89 is the answer. And y'all let me know if you know how to find the others, because I don't see any way to do it with the size of these numbers and the fact that there's no real clear way to factor these parenthetical quantities on the right. Okay, and I don't think he knows. Half vegetable and half animal, right? Okay, thanks for viewing.